Hello everyone, reporting today for First Updates Now, I'm Abbas, and with me here is Team 15167 Robo Troopers from Virginia. They were the finalist alliance captain for their division at the Chesapeake Championship a couple weeks ago, and they just have an absolutely amazing robot, super compact, some of the best driving I've seen this season, and there's just so much going on that I want to talk about with 15167 Robo Troopers. All that and more coming up on First Updates Now.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. Check out our all-new FTC content coming to Fun's YouTube, including new hosts from the FTC community. We'll have resource guides, top 10 moments, behind the bots interviews, and walkthroughs to help your FTC team improve at youtube.com/firstupdatesnow.
Okay guys, let's get started with your drivetrain. It seems very, very compact and also has some really cool underglow to it. So walk me through what went into making it and if it's changed at all throughout the season.
So let me first turn over the robot. So as you can see here, we're using 3-wheel odometry, which is sprung so for optimal tension. And also we have these guards, so make sure like when we're driving in auto, make sure like the init cone does not get stuck on the wheels. So that's one reason why we put this. And also we use vertical motors so we can conserve more space when we're when building a chassis.
So for the exact specs of the motors, we're using 312 Kubota motors. We're using miter gears so that we can have them vertical, and that's basically all of what our motors for our drivetrain.
Yeah, and so like I see that you guys said you want to put your motors vertical so you can conserve space. This does raise your center of gravity, however. So have you guys had any issues like with tipping or anything like that, or have you been able to combat that in other ways?
Yeah, I mean, we've had a lot of issues with tipping like this season. In the Chesapeake like state championship, we tipped like, or actually, the only reason we tipped in the Chesapeake championship were not because of the center of gravity, but in previous competitions we have tipped due to driving at a high speed with our center of gravity for the robot being very high.
And so yeah, like what did you do to compensate for this? And like what advice would you have for other teams that are facing a similar issue?
So one thing we try to add like a slew rate limiter on our drivetrain when controlling it with the controller. So it basically controls when it deaccelerates and accelerates. So it makes sure that we're not speeding up immediately when we have our slides open or on the top.
Sure. Yeah. And so going into your claw, from the looks of it, it looks like you guys have some small wheels in your claw, but they don't look quite powered. So if you guys could give me an overview of how your claw works and any iterations you've gone through throughout the season, and we can talk more about it.
So our claw is like, the wheels in our claw they don't spin at all. They're just for grip for the claw, or not for the claw, for the cone. So with our previous claws, we just had like a flat grippy material on the curve of the claw, but we had issues with grip with that, and then the cones would fall out of our claw. So with these silicone wheels, they grip very well onto our what's it called, cones, and it gets rid of the dropping issue with our cones completely.
Sure. And so was this something like at what point in the season did you realize you had to add this, or like when did you add this? And like how did you figure out to use wheels that weren't actively powered or not powered at all, that were completely static?
So for our first and second qualifiers, we used like Sonny said, a normal claw that did not have any wheels. For our third qualifier, we used green compliant wheels from AndyMark. We mounted those onto our old claw that just had grip, and that helped a lot. But we noticed that it was really heavy, so we designed a new custom 3D printed claw, and we silicone molded these wheels using a 3D printed mold, and this helped a lot, especially at the Chesapeake States.
Yeah, that's fantastic. And so now talking about your arm, I mean, you guys have it up there perfectly. It's pretty long, like compared to all the other arms I've seen this season, but you guys control it extremely well. So let's talk a little bit about the hardware and then also the software behind being able to control it so well.
So one thing we use to control arms to make sure that it doesn't like bounce around when we're like slamming it this way is that we counter spring the arm to make sure that the force of the arm goes opposite from the direction is going. And
Yeah,
also in
and
our software side, we make sure we use motion profiling to limit the acceleration and also a gravity feed forward gain, so it counters gravity.
sure. And
We
so
also have
with this counter springing, like how did you guys develop it? Like, was it something sort of that you had to try a bunch of different springs at or a bunch of different positions, or did you just like get it right the first time?
so our counter springing, we just had like one revision with it. We had issues with like the arm, the motor was another thing the counter springing does is it makes it easier for the arm to lift up. And we have two sprigs here, two extension sprigs, and we just mounted them onto the U channel where our 117 RPM motor is mounted. Two of them onto the top of the arm over here. It was just one revision, and it works basically perfectly, and it makes the arm lifts very easily.
hmm And so you are using a motor then to control your arm, not servos.
Yes.
Yeah, because we required a lot of torque to move the arm up.
Yeah, and the
hmm
arm is very heavy too, so we do need a motor.
Got it. And so I see that you guys have like the chain going along the length of the arm. So is it like just a normal virtual four bar, or are there some other like actuation components to it?
No, this is just a normal virtual four bar.
hmm
We just have sprockets on our dead axle right here. We have another sprocket at the end of our arm, and this makes sure that our claw stays horizontal all the time.
Sure. Yeah. I mean, sometimes simple does it, right? So going on to your lift, give us an overview of it. Like from the hardware, it looks like you guys are using belted slides for your lift, which is not the norm. Teams usually use like some sort of string and pulley system. So what was the decision behind using belts for your lift? And is this something your team has a lot of experience with?
So a lot of teams that they use stringed slides, and we found early in the season, in the off season, that it was really hard for us to tension it, and it always got untensioned. So we decided to switch to belted slides, and after many iterations, we finally perfected it, especially by continuously iterating our belt tensioners. Originally we just had like a clamp that just clamped down the belts, but now we made sure it's like in a nice secure loop, so then it never slips.
hmm
And then with the belt tensioner, all we have to tighten the belt. All we have to do is just screw in this one screw, and it tightens the belt by pulling these closer together.
Yeah,
Another
that's
problem, another
that's
problem
really
with
cool.
belts that we had earlier in the season was that we used GT2 2 pitch belts, and that would slip on our pulleys a lot. So we decided to change to GT3 pitch belts, which helped a lot when giving traction of these little teeth on these belts.
Sure, sure. And so, like, now reflecting back on it, would you recommend teams to go with belted slides, or would you probably want to, like, try a string or a different system for powering your slides?
Yeah, we would definitely recommend teams to switch to belted slides. Also, have you seen Go Builder has also tried to influence other teams to use belted slides with their new system. So yeah, we've been like telling people on the FTC Discord to switch.
Yeah, the biggest reason we tell other teams to use belted slides is because they're so much more robust than string slides and help a lot during competition, especially when you're banging around other robots.
Mm-hmm. Sure. And so, you mentioned that GoBuilder came out with this new belted slide system. So, would you consider like replacing some of the 3D printed components on your belted slides to be to use like the GoBuilder components if the belt profile, like the tooth profile fits?
I don't think we would change our 3D printed parts to use the GoBuilder ones.
hmm
I'm pretty sure GoBuilder ones are metal, right? I can't
Yeah.
Yeah.
remember. Yeah, so with the 3D printed like belt clamps and everything, and like the slide mounts, they're lighter. It makes lifting our lift easier, and it's also more compact and more low profile, which fits our design better.
Sure, sure. And so I think the last thing I want to bring up with your guys' design is you have that junction alignment tool at the back that kind of comes out every time you're doing a cycle, which leads to some of the fastest deposits we've seen this season. And so walk us through how that works. And there's been a ton of rulings around, junction alignment devices this season. So how it's changed, and any advice you have for teams who are looking to implement a similar device.
So currently, our Junction guide, as of now, is illegal, but in CHS states, it was legal because now there's like a 4-inch diameter requirement now. But so this one worked pretty well for us, and because the main thing we did was to drive in, we just make sure that the pole always comes here and always aligns perfectly in the middle, as it was always a trouble we had in our first qualifier where we always miss cones. And one thing we want to make sure is that it's not it's longer rather than wider, so that we have more room for error when trying to align the pole.
Sure. And so, like, has this been like just the first version of your junction aligner? Or have you made any like critical changes to it that made it work a lot better?
So originally, I mean, as you noticed, so this our junction aligner is using a servo with a linkage to make sure that we don't when we bang into other robots, this doesn't break. Originally, we had it straight mounted onto the servo, and we broke a servo from that. But now we use the linkage, it's much easier. Another thing that we iterated was this 3D printed part. Originally, we just used a metal part with Gobilda that was a custom built. But now we just realized that we could just 3D print it, and it made it a lot easier.
We use the Go Build It parts to find the right dimensions and the right like angle for these beams. That when we 3D printed it, it would work best with our design.
Yeah, that makes a ton of sense. You know, you can quickly iterate and prototype with commercial parts that you already have, and then for the final design, you can make it to all the specific dimensions that you'd like. And so, Robo Troopers, like the last thing I want to ask you guys about before we end the interview is your guys' driver practice. Like, you guys are just so fluid around the field, just back and forth every cycle. So what does driver practice look like for you guys? Do you think there's anything special that you guys do that you would recommend, like first-year teams or even experienced teams that are looking to really elevate their teleop game?
So I drive for our robot. I'm like the solo driver for the team. So one thing I highly recommend are these like PlayStation DualShock 4 controllers. Compared to the Logitech controllers and the EdPart controllers, we found these to work very well with us because we've had issues with like stick dead zones with the other controllers for them being really inconsistent. And we find these to work really well. What we do is we set up like a full field and we just practice continuous cycles around the field like again and again to make circuits.
Mm-hmm.
And then with that, we find out the best strategy for driving, where to drive first, to like place the cones first. And also, we just experiment with like different cone placing strategies and driving around the fields in different patterns and stuff.
Sure.
Yeah, and especially when you're practicing with defense, if you have like another team which you work with, or you can have like another bot, you can always practice your defense by showing how you can ram into other bots and then deposit over them.
Yeah, definitely. So, Robo Troopers, thank you very much. You guys did fantastic at Chesapeake. You know, unfortunately, you didn't get a ticket from Chesapeake to the Houston World Championship, but there's always a bunch of off-season events. I think you guys were at CRI last year, and, you know, always very competitive. So, thank you so much for this interview. Reporting for First Updates Now, I'm Abbas.
Thank you. Thank you.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for first students are now available. Get more information at kettering.edu/first. Check out our all-new FTC content coming to Fun's YouTube, including new hosts from the FTC community. We'll have resource guides, top 10 moments, behind the bots interviews, and walkthroughs to help your FTC team improve at youtube.com/firstupdatesnow. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.